take a look at position vectors. This question tells us OA and OB are position vectors relative to the origin O. All right. Given the points A is 610 and B is -3, -4, write down OA and OB as column vectors. Part B says express AB as a column vector. And part C, calculate the length of AB. So we are going to look at these questions one time. A is equal to 610. And we have B is equal to -3, -4. All right, we have B and B here. So part A wants us to put it as a column vector. So column vector is simply a vertical format. Here is a horizontal format. This is more of a coordinate, right? An ordered pair. We want it in a column vector, so it's a vertical format. So OA B all right, so from the horizontal format, we put it as a vertical format, right? So that's part A right here. Let's deal with part B now. Part B tells us express AB as a column vector. So we need to find out what AB is. Now, sometimes the question gives you a diagram. And from the diagram, students use that diagram to calculate or find out what AB is or CD, whatever two vectors they give you. All right. You don't need a diagram. All right. So if you have to find out AB, all right, if you have to find out AB, since we are dealing with position vectors, which is related to the origin, right? It just simply means if we need to find out AB, we're going from A to the origin. So from A, you're going to the origin. And then from the origin, you're going to the next vector. So plus the origin to the next vector, which is B. So AB is simply AO plus OB. A going to the origin plus the origin going to B. All right. If I want to illustrate this on the diagram, right? This is the center O, right? So let's assume this is E 610, right? And let's assume across here, this is B, -3, -4. All right. Right, going from O to E, O to B. So we went from O to E, which is 6, 10, O to B, -3, -4. This is just an illustration, right? So this is just an illustration of how the diagram may look, not drawn, but in this case, it's not drawn to scale because I don't have a grid. All right. So if they ask you, okay, what is AB? What is AB equal to? Right. So AB simply means AO plus O going to B. Right. This is not drawn to scale. Just put that note there one time. All right. Now you don't need a diagram. All you need to know if it's position vectors, you deal with the origin. AB is equal to E to the origin plus the origin to B. Another thing to note is OA is 610. OA, this is the direction of the arrow. O to A is 610. So A to O, opposite direction, you change the signs. -6, -10. Same with OB is -3, -4. If you deal with BO, it will be 3, 4. Change the direction of, its opposite direction. So you change the sign. All right, so let's work out this question now. So we have AB is equal to AO plus OB. So this is equal to right, AO, change the signs. I'm just putting all the work in. From here, you could have put it in your calculator, or from here to get your final answer. All right, so here, this is the column vector for AB. So this is part B. All right, this is part B. Let's look at part C. Part C asks us calculate the length of AB. Calculate the length of AB. So for part C, right, this is what we write to calculate the length of AB. That is equal to square root of 81 plus 196. All right. Square root of 277 and the square root of 277. All right, that sticks a little better. Two decimal places. All right, so this is how we calculated the length of AB. All right, the length of AB. This is the procedure here. Remember, in fact, calculating the length, it hinges on Pythagoras' theorem. All right, this is how we calculate the length of AB. So that's it for position vectors.